What's up, guys? Welcome back to Wrenchingwrecked. It has been a hot minute since I've actually even been to the barn. I mean, I've been here for briefly, a couple minutes here and there. But this thing's ready to go home. I just got to put one bolt in the seat. And then I think he wants to add a passenger peg type design in the rear using grenades. Why not? So he actually dropped those off. I'll show you that in another video because we're not messing with that bike today. And the Cowie has a properly sized battery in there, ready to go. We just got to spray some starter fluid or something in there, try and crank that off. Or I did bring the reservoir, the little bottle over. Sporty's primered. And then in these Amazon boxes / those two bags are the brake rebuild parts for this bike. So we're going to dive headfirst into that one. I was going to pull the carbs, but we're going to hold off on that. That's where we're at on the bike stuff for right now. Dottie's mini bike is coming along. She's got the seat and stuff done. But again, those will be in a different video. Today, oh, here's the grenades. Grenade foot pegs. Should be fun. Just got to figure out how to mount those up. Anyways, if we come over to this table, here's what I've been doing. And if you want to know more, look at somewhere else on YouTube. Unfortunately, it would take me forever if I tried to explain all of this. This is a 7.5 horse Leeson motor, electric motor, 3-phase. So this 7.5, yeah, the shaft's kind of pitted, beat up, does not matter. This is a 3-phase electric motor. I spent the last day and a half going through, well, really not, I've spent a couple hours, but going through all of this. This is a phase converter. I have 3-phase power at the barn. I do not have 3-phase power at the powder shop. I need 3-phase power to run the new big Torrit dust collector that I just picked up for up there to kind of siphon off some of the dust from the exit exhaust setup that we have over at the blast shop. Torrit 3-phase VS 1500, pretty decent machine. It's probably still undersized for blasting, but we're not really doing big industrial blasting over there. I just need something to kind of filter and sift out a little bit more of the crap that's getting kicked out because my neighbors are getting a little upset. So I'm working on it. Scored that really cheap. Only problem is it's a 3-phase electric motor. I don't have 3-phase power up there, so here's the solution. I have plenty of experience using capacitors on compressors. We have a 10-horse single-phase electric compressor over there. It burns up capacitors. That's my biggest complaint. It gets hot, especially in the summer, and eventually one of the caps runs out or blows up, and it will do the try and start and then lock up, and the hum of death, as I like to call it, just and it sounds like the motor's seized up, but it's really just one of the capacitors just took a crap. Granted, once they get hot, or even if they're going out when they get hot, they don't like it, and it starts making weird noises and doing funny things. For a 3-phase motor, there is a way to convert single-phase into 3-phase, and that's a rotary phase converter. There's a bunch of different options. You can also do a VFD or VSD, variable speed drive, variable frequency drive, single. The dust collector technically has 2 motors on it, and as far as I'm aware, and I could be wrong because I'm not an electrical guy at all, but a static phase converter, which is a single box, which it basically adds as a jump starter for a 3-phase motor. That could work for a single 1-item unit. Same thing for a single motor application, but it's usually not the cleanest phasing. This is a rotary phase converter that I just kind of reassembled. I bought a kit on this one. I have a million capacitors sitting around the shop, and honestly, I probably have all the parts I need to do this, but having never actually set one up and set it to scale, it's just how many caps you're running to run it in series. I just bought a kit. Still reasonable. I think a brand new one with the 7.5 motor, you're probably looking $1,500, $2,000. My buddy got this one for free for me. Reached out to a friend. They had a million of these sitting on the shelf. Just used old tear-off motors. I don't need it to power. I don't need it to crank over or do anything crazy. We'll see if the bearings are shot on this. There's not too much to rebuilding an electric motor, provided the windings are good. Unknown condition, but we're going to give it a shot, and it cost me nothing. This kit, with the box and all the caps and all the wires pre-wired, like this, came from, I'll show you, Powerline phase converters. I think they were out of Wisconsin, if I remember correctly. Don't quote me on that. But ordered it through them. Parts showed up 3 days later. basically one box. This was all capped off closed. These were in boxes. Opened it all up, wired everything up. So quick down and dirty of how this works. We got a toggle switch up top, contactor up here, contactor here. So essentially, the way that this is currently laid out, this contactor is going to be my main wiring in. So I have 2 poles left up top. This is going to be my standard for a 220 wiring. So you got 2 hot leads. Regular house wiring, you got 110. So you got a hot and a neutral. This is a hot and a hot, which will then kick off, run down through the capacitors, through this terminal block, through the relay, through everything else, through the other contactor. Capacitors will unwind, and then I have 3 terminals right here. These bottom 3, I labeled them. It's going to be really hard to see, but this is our output 1, 2, and 3. This is our motor 1, 2, and 3. These are bridged. So essentially, the quickest, easiest way to say how this works, since I'm not the electrical guy, don't ask me specific questions. There's a million videos on YouTube, but essentially we're going to be taking power in, L1, L2, coming in here, and I'll have 3 legs of power out down here, 1, 2, and 3. Okay, that should be how this all plays out. These will run in series, and then we will run power back out to our new equipment. So today's goal is to tap this motor into this, hook it up to the open electrical welding box that I already have that's wired for 220, run some jumpers off those wire nuts, and see if this thing will start up our 3-phase rotary motor, and go from there. So I will have to punch a hole in the knockouts and run a couple wires through there. I don't know what I have for connectors and grommets and things yet, but we'll, down and dirty, we're just gonna get it set up, crank it over, see if it works, and go from there. Let's see how this goes, and hope I don't electrocute myself or blow up some capacitors, because that's never fun. I cannot stress enough that this is only for testing purposes today, so this is not going to be wired in finally in any way, shape, or form. But my buddy was nice enough to go through and lay out these for me and label them. So he wired these ones up. This was our 4th one. We don't need that, but we have 1, 2, and 3. So we have L1, L2, L3. Okay, so this is our motor outputs. So what I'm going to need to do here is make a connection between M1, M2, M3. And I'll just run them. It shouldn't matter directionally for spinning on this, but depending on how you want the motor to spin, you can actually switch L1, L2 opposite, and it should turn the motor the other direction. But for now, we will cue this up for L1 to M1. I don't think this is going to matter. I am going to need a real small screwdriver. I have a million knockouts on this box, so we will punch these through and actually set these up at some point. But for today's purposes of the experimentation phase and see if this thing's even going to turn on, we will try it this way. I know I got the box tipped, you can't see much, but I'm just hooking up one wire here to my motor connection, M1, which will come over. How much room do I need? Trying to see, maybe I should just clear this bench off, huh? And do this over there. We're only doing little jumper wires to that panel because that's the closest one I got. Well, the closest one without taking a bunch of stuff apart. Let me do that. But M1 is hooked up there. This will go to L1 right here. And he hooked me up with the Wago connectors, so this shouldn't be too terrible at all. But let me clear out a spot. I'll move the welder over and set this stuff over on that workbench, and then we can see what happens over here. Let's talk about things that are heavier than they look. 7.5 horsepower 3-phase motor is not light by any means. So, grab our phase converter box and whatever wires I just started laying out here. So it's going to be much easier with the connections all being super close. So we have this laid out. What did I say? This goes to L1. L1. So again, I will say this a million times. I know I'm going to repeat myself a ton, so get used to it. But L1 is, or sorry, this is only for mock-up. I am not overly concerned about OSHA standards or anything like that right now. This is strictly for testing purposes, because there's a good chance this might not even work if I wired something else up wrong. I checked and rechecked and got it all set up where it looked like it made sense, but there we go. M1, L1. Just like that. Screw terminal here, and then 2 will go to 2, 3 will go to 3, and then all I need to do is tap into these 220 leads and run 220 into these 2 terminals, and then we click the switch on and off. See what happens. I do have a separate breaker back there, so I don't need to worry about killing electricity to this, because there's a separate shutoff for the air compressor in back. So this won't be too terrible, I don't think. I'm not color coding or labeling anything. Well, on this I don't really have to, just because I have my terminal block labeled already. So this one will go to L2. Then we can figure out what direction this needs to spin, but it shouldn't really make a difference. This essentially is a box that will start this electric motor. As this electric motor is running, once it actually starts, that potential relay should get a back signal of electricity from that motor spinning, because it's an electric motor. Once that's spinning and winding up and running, it's creating electricity. That electricity then runs back through the panel, through the run capacitors, which should actually even out the third leg. And then the way this is wired, essentially, this L1 and L2 terminals that are coming into this panel, so these two, the hot 110, 110, these 2 hot leads go in through here. Those are powering L1, and I don't remember exactly if it's L1 and L3. How I have it wired up, I can't remember. I did this 2 days ago. But it is going to send 110 to one leg, 110 to the other leg, but it's bridging off some of that power. We still have a third leg that needs to get power. Otherwise, the motor will not run. Well, if you divert the power back through, get this motor spinning creates the false ghost leg or third leg of electricity for a 3-phase system. If you hate wiring and this is not your cup of tea, I do not blame you. I vaguely understand it. We've had enough equipment over the years to give me enough confidence to do stupid things like this and try and figure out how to do it myself. Do not recommend going that route for everybody. If you know you're terrible with electricity and don't understand this could be dangerous, I'm not gonna lie. So there's my disclaimer. Do not try this at home. Call a trained professional. That's not me. Or look up other people on the internet that are way smarter than me. But none of this is new. This is not like some weird crackpot thing. These things have been around for a very long time. I have buddies of mine that have run and built these for much more heavy-duty 20, 30 horse equipment, lathes and mills and all that fun stuff. This, I just need this to start a 3-phase electric motor and turn a fan. It's basically just a big, giant, glorified fan at the end of the day. But we'll see what happens. It is kind of fun going through and building these yourself. Even if you're not a wiring fan, it is kind of, I don't know, getting an instruction page and all that other stuff. I spent enough time looking at videos on how to do this like DIY budget, where you just buy the capacitors and you kind of slap everything together. Not opposed. I thought about doing that because it would have saved me a good chunk of coin. But honestly, this electrical box that this came with, comparable ones for me to buy were around 70 or 80 bucks. I'm fairly certain this kit was about 180 or so shipped, with everything kind of figured out for me. So all I gotta do is come in and trace some wiring diagram and lay some stuff out and try to make it look moderately decent. And that part doesn't even matter all that much, but there we go. Now we have 3 legs of power hooked up. So we should be good there. 3 legs from the motor side. Then I need to cut 2 little jumpers to tie into these wire nuts. Hopefully those will be big enough. If they're not, we'll just take off that outlet part. It's a quick and easy one since I never hooked that panel up. Shh, don't tell anybody. But we'll splice off the ends of these. And these will be my 2 hot legs coming in. And I'll start down here in the box. Maybe that's probably better, huh? Now you can see the panel. But L1, L2 should not matter which is which. You could also put spade connectors on here, but for right now, we'll drop this in. I wired up that switch right. That was the only part I wasn't really sure on. It doesn't matter. It's either going to turn on while I'm back there, or it's not going to turn on until I come back and hit the switch. All right, what do we need? About a foot here. This is just old scrap wire that I've had laying around here, so don't expect all that much. Ooh, this wire's seen some heat at one point. These are probably the old oven wires back when we were on electric. Looks a little torched. At least the outside of the coating. But it's okay. Safety first. 3rd, 8th, 10th, something. Fingers crossed this all actually works, but set this over here. Hopefully this won't dance around. 7.5 horse motor. Maybe we should put a clamp on that, huh? Before we actually cycle this thing on. These are dead, so we'll pull this. We'll pull this. These 2 should not matter. All right. Now our leads for the welder are disconnected for the quick plug one, which is fine. Take 2 more of these. This goes to 1 leg, like so. Man, I even left the cover panels on here and I still didn't hook them up. Way to go. Half-assing everything for 20 years. And 2, I need a little bit more than that. 1 and 2. Okay, so this is the last wire nut we need to hook up. But essentially, when this is tightened, come on, grab, there we go. We have 220 leads coming through here, through the conduit. 220 voltage, single phase comes in. We got a hot leg, goes through the contactor, goes through all the switches, goes through everything else. As far as I'm aware, I have this wired off with this is off. I should really throw a voltmeter on there and check that real quick. And I should try and get this in a position or clamped. Maybe I can do 2 clamps or something right here. This is gonna, in theory, if I go to click that breaker on in the back, there's a good chance that that will hard kick and try and hard start this if that switch is off. Yeah, let me throw some clamps on there. Okay, I couldn't find my welding clamps. I know they're here somewhere, but the whole shop is trashed over in this corner and I need to go through and clean. That's on my weekend agenda outside of this. So I just grabbed a couple way too long of wood screws, and 1 in the back, 1 in the front, through this crappy broken toolbox. Should be good enough. So I'm gonna run around and back. Fingers crossed, when I click this breaker on, nothing happens because that switch is off. But let's find out, and I'll leave that rolling, so I'll see when I come back over there. Switch on, nothing happened. Okay, that's what it's supposed to do. And now, the fun, scary part. All right, that was absolutely perfect. That never happens in my life. Okay. There wasn't even a hesitation there. Holy crap. yes, I could have saved money and I could have just run the capacitors that I have, literally extras of sitting on the shelf, and then adjusted and had to measure things. I should really go through and take a amp gauge and figure out what these legs are. But in theory, that should give me 3-phase power. We can grab a voltmeter. Do I have my voltmeter up here or did I bring it with? Let's see. If I get my voltmeter, we'll plug it in and see how that looks. But Jesus, that's about as good as it gets. No hesitation, no weird engine whining noise. That sounds healthy. So that's right now running a 3-phase motor on single-phase power. So now this will send a current back to those 3 output terminals back here. That's what I use to wire up my outlets for the actual equipment. So I'll be darned. We did something and it worked without any drama, other than cleaning up the wires and running that through conduit and getting that set up proper. All of this needs to get installed in the very back corner at the other shop behind my paint booth. It's in the back corner underneath 2 feet ducting for the exhaust fan that's already set up over there. I will not be filming back there. It's dark, it's cramped, it's miserable. It's just not gonna happen. But if I can get back there once everything's set up and laid out, then we will. No promises, but that's kind of where we're at right now. So I'm feeling really good about this. Other than that, that's pretty much gonna wrap this video up for now until I can get the other stuff set up and get some 3-phase output power coming through this thing. But I'll be darned. This thing, I was expecting troubleshooting, diagnosis, that started really well. I'll take the win. Thanks for watching. Like, comment, subscribe. Hopefully we can get back to jamming on some bike stuff in here. That sporty frame that we hardtailed was supposed to get sent home. Well, now I think that's turning into not a full build, but at least a mock-up, so I can get everything kind of laid out and see what it looks like. So we got a 16 wheel down here that we're gonna throw on there. I got a crusty, we're taking up all the crusty parts and laying it out to figure out what he wants to do, because it's his first bike and he's asking for a little bit of insight on how to build a chopper. Don't know why he came to me. I just slap things together and see if it works. But I'll take it. Thanks for watching. Like, comment, subscribe, all those fun things. We'll catch you on the next one. Working on that motor the other day. It's a little dark over here, so I didn't film anything. Got one little mag light up top to light up this back area behind all the ducting. But Harbor Freight started selling these bigger Cyclones. It's nice. It's like a 16-gallon on-wheel container. So there's little quick clamps here that come off. Basically, if you're not familiar, I mean, woodworkers use this stuff all the time, but it's basically a cyclone. So the air gets pulled in through this hose to this cyclone. There's an inlet that goes in, it kind of spins around, and any of the heavier particles will settle and drop into the bucket. The light, real fine stuff will come through and get collected into the actual collector here. There's another big filter box here. So I got the motor setting here. I will put this on a board at some point. I got the phase converter panel mounted on the wall, and then kind of tidied up most of the electrical around here. I used to have a compressor back here, so the wiring for this is already done. I got probably 6/0 coming down into this panel, maybe 4. It's really thick on the 2, L1, L2 coming in for the 220 leg. Got that switched over to the blast fan, or the powder booth fan, and this is the Torit dust collector that we picked up. So probably could still use a bigger one if I was going to run it strictly on this, but this is basically piggybacking off of the ducting system we already have. So I got 2 things set up here. Behind the ladder, that wall is the blast booth at the small shop. So if you look, this ducting runs up and down. I got a massive fan up in the ceiling that pulls air up, and then a handmade cyclone inside of there. You can take a quick look. It's pretty haggard, but it's been working for 10 years since we've been up here, but well, at this shop. So it's not the best. Definitely could use some more CFM on that, and then a better filtration system, but this does work. This gets basically dropped down into a 5-gallon bucket that we empty daily, And then the new inlet is here. So basically we're extracting dust through a filtered setup versus the venting it outside. Still needs work, but it's kind of limited by where we are at location-wise. Anyways, if we come back over here, let's try all of these things now that I got it all wired up and hosed in. Harbor Freight Cyclone was I think they're like $3.29 without a coupon. They had a 20% coupon last weekend. I just didn't have a chance to run over there, so that kind of sucks. I paid up a little bit, but I needed to get this thing set up. Does not come with ducting hose. So it does come with a little Y block and this adapter at the top. So basically dirty air goes in the side, clean air comes out the top. Heavy sediment drops into the bucket, and it looks like we already got some stuff in there. But this goes on top so you can size it up for whatever size hoses you're running. I'm running 6-inch hose on this because I want maximum efficiency here. The ducts on this are 6 inches and then 6-inch piping. So these were 50 bucks each, so that was 100 bucks in hoses. I tried with the aluminum stuff, but that's just so paper thin. And that's kind of where we're at. So this is it says 280, but it has been rewired for, or 480, but it has been rewired for 230. Hence the little tiny label there. I should cross that out, but whatever. It all works. This, oh, my capacitor, start capacitor on this motor is going out too, so that was supposed to be here. I was hoping to get that fixed up today. Really, I've just been spending all day doing maintenance. But here's the phase converter, here's the motor. You might have seen that in the shorts on the real rough setup, but we do have live power coming into here. I am going to be putting in a switch instead of the toggle, just a separate switch here. I just got to get a 221. I grabbed the wrong switches at the store and got 110s, and I need a 4-prong for the switch there. But starts right up, motor is spinning. So normally I fire that up, make sure the motor's going. Again, that will get put on a wood block of some sort, and then there we go. We're rocking and rolling. See the ductwork just click on over, and tons of debris and sediment picked up. You can see it, these are crystal clear. Now it's still dark back here, but it should be working. We'll be up here blasting tomorrow, and we'll get to find out exactly what happens. And then this should have an auto vibrating motor in it. I don't know when that cycles. I don't know if it's when you turn it off or what. But pull it there, let that wind back down, and it's off now. That'll still power to the electric motor for the phase converter, and that's it. So the nice thing is, this is my first time doing one of these for a 7.5 horse motor, which is technically just undersized. This is a 5-horse dust collection motor that should be running a 10-horse phase inverter, but my buddy got me a 7.5 and I didn't have to pay anything for it. And it seems to be firing up and working just fine for now. Is it the most optimal? No. Did I put an amp gauge on and measure the voltage across all 3 legs? No. Everything sounds good. We're gonna run with it until we have a problem or anything goes wrong. So that's the end of the little electricity conversion video that I didn't really do a full detailed build on or anything, but that's what I've been working on. It's been keeping me busy the last couple days. Now we get to go over and start getting the diesel compressor ready for winter, which means putting in a block heater. So I don't have to worry about trying to lug that thing in and out of the shop all winter long when I need it. So hopefully that goes pretty smooth. But until then, we'll catch you on the next video.